In the next series of questions that I'm going to have you do, we're going to connect up all the concepts we learned about kinetic energy and potential energy and the conservation of energy all together, right? So here we have a problem of a roller coaster where we have a 535 kilogram roller coaster that's been overlaid on a graph showing its height at the various points. So there's going to be a series of questions asked here, but ignore the real life situations and the effect of friction and air resistance that exist. Okay? So my first question to you is, at 3.5 seconds, so at the peak here, what would the potential energy be in the roller coaster? So pause the video and see if you can do that. So hopefully you remember that potential energy is equal to mass times gravity times height. If not, it's given to you on your formula sheet, nothing that you have to memorize. Right? And off the graph that we read off that the height is at 100 meters and the mass is at 535 kilograms stated in the question, and you ended up with this potential energy. Now, for the purpose of Science 10, we're not going to round this to the 3 significant figures. We can just leave your answer as is. On the next question, you're asked to find what is the kinetic energy at 6.5 seconds. So at the bottom here, what would the kinetic energy be? So hopefully you came up with the kinetic energy is 524,835 joules. Right? We can do this without calculations. This is at the bottom of the roller coaster, so all the potential energy has converted into kinetic energy. We're assuming no losses to air resistance and friction, so all of the potential energy got converted into kinetic energy. In the next question, we're asked to find what is the kinetic energy of the roller coaster at 8 seconds if the velocity is at 34.3 meters per second. So around here, what is the kinetic energy? To answer this question, we had to recall what the kinetic energy formula was, which is equal to 1/2 mv squared. And we plug in the values for the mass and the velocity, hopefully came up with kinetic energy is 9,175 joules. The last question I'm going to ask you on this page here is, how high is the coaster be able to go back up that hill? So after this point here, how high can it go? Can you come up with a strategy to figure that out? Apply what you've learned to determine how high can that coaster go back up. Hopefully you came up with 100 meters. The math here isn't difficult, but it's the concepts I want you to understand. Right? So in this question, we're assuming there is no loss of energy. So everything gets converted from potential energy to kinetic energy. If the roller coaster started here and moved down, all the potential energy got converted to kinetic energy. At this point, it's going to go, all the kinetic energy is going to turn back into potential energy. So how high can it go? Well, how high was it when it started? It started at 100 meters. So if we're assuming no loss of energy, it should be able to get back to the height that it was. So it should be able to get back to 100 meters. In reality, we know that's not true, but in this ideal situation we're setting up, we're going to say 100 meters.